Hi, welcome to QI Bitesize. My name's Emma Donaldson and I'm the Improvement Advisor for Tickle. This is Module 4, Variation. So, why do we need to understand variation? One of the reasons we plot data over time in quality improvement is so that we can understand the variation in our systems. All processes and all systems vary slightly from day to day, and this is normal. Understanding this variation is critical in being able to improve these systems. So why is it so important? If we don't understand variation, we might have a tendency to deny the data because the data doesn't fit with our view of reality. We have a tendency to react to trends, either positive or negative, that aren't there. We have a tendency to shoot the messenger and try and explain our data away. All of these common psychological responses to data are unhelpful, and understanding the variation and what's common and what's not common within our data is important in being able to move past this and achieve quality improvement. There are two key types of variation, and the first is common cause or random variation. This occurs in all our processes and all our systems on a day-to-day basis. Everything varies a little bit, and all of these variances add up, and therefore the whole process varies over time. So let's look at an example. This example deals with the time from presentation to the ED to first dose of antibiotics in a patient with pneumonia. And that process varies over time because of all the little sub-processes within it that vary over time. So on any given day, the amount of time it takes you to see the first doctor, for that doctor to order you a chest x-ray and that to happen, for that chest x-ray to be reviewed, for somebody to write up your antibiotics, for those antibiotics to be drawn up and finally administered, each of those processes will take a little bit longer or shorter than it did with the previous patient. And therefore the whole time from arrival to antibiotics varies slightly on a patient-to-patient basis over time. You can see on the chart below that each patient is the summation of all of those individual processes, and the total time from presentation to antibiotics can be plotted as a single data point, the red line on top of the bar chart. This is normal variation. It's random and it occurs on a daily basis. There is, however, a second type of variation which is non-random and is called special cause. And the system can be influenced by big outside factors that are not usually present. And the size that is produced in the system is big in comparison to the normal variation of processes occurring day to day. It's much less frequent than common cause variation. Going back to our example, from patient 9 onwards you can see a single large red block at the bottom of all the processes. This is because a major incident has occurred and all of the patients are taking that much longer to triage as a result of being lower priority than the multiple car pile-up on the motorway. You do not need to redesign your A&E processes for dealing with patients with pneumonia based on a single incident that happened on a single day. You need to look at the common cause variation that happens every day to design a reliable care process for these patients. So, in summary, in order to understand and improve our systems, we need to first understand the variation that exists within the processes of these systems. We need to understand whether that variation is common or random or special, non-random in cause, because the response to the variation depends on this. We can understand variation in our data by plotting our data over time. And we can apply rules to the data to understand whether or not a significant change is occurring. And we'll look at these in the next module. Thank you very much for joining us, and I hope you found that useful. I hope you will join us again for further modules on QI Bitesize. We really welcome your feedback, and you can follow us on Twitter @tickle_northwest or myself @E_Arnott Smith. We hope you can join us again soon. Bye!